Today's lesson is finding arc measures. Okay, a central angle from our vocabulary is an angle whose vertex is on the center of the circle. The sum of all central angles in a circle is 360 degrees. Oops. What's going on here? Okay, so if I go all the way around, so the center of my circle in this example is C. So a central angle in this particular example is going to be angle ACB, or I could call it angle ABCA. So C is the vertex, and that is the center of the circle. So the central angle is actually 50 degrees in this example. Okay, so by definition, a minor arc is less than or equal to 180 degrees. I'm sorry, it's just less than. Shouldn't say equals here. A major arc is 180 degrees or less, and a semicircle equals 180 degrees. So a semicircle is a major arc. So a minor arc is named by two endpoints. So I name it by two endpoints. Okay, so I can say arc. So an arc is a portion of a circle. So I can say arc AB. So here is an arc AB, and I draw it with a arc symbol. BD is another arc. So arc BD. So I draw it with an arc symbol. AE would be another arc. AE. So all of these are less than 180 degrees, or DE is another arc. So I name a minor arc with two letters, and it has to be less than 180 degrees. Okay, a major arc is greater than or equal to 180 degrees. So these I name with three letters, and I go in the order of the letters. So one arc is going to be angle EAD. So EAD. So this is greater than 180 degrees. So this is arc EAD. So I name it with three letters, and I'm going in the order of the letters. Another arc I could name is EBD. So I could name the same arc as angle EBD. So instead of naming A, I named B. So I need to name three letters, and it has to be greater than or equal to 180 degrees. So another arc I could name is EBD. So EDB, I could go in this direction. Okay, so arc EDB. Okay, and a semicircle is exactly equal to 180 degrees. So again, I'm naming with three letters. So I can name this one, which is 180 degrees from here to here. So this would be angle AED. So it's a major arc, so I name it with three letters. Or I could be naming this arc, which is angle ABD. So I know which half of the circle I'm talking about. Okay, arc addition postulate. Just like I could add segments, I could add angles, I can now add arcs. So the measure of an arc formed by two adjacent arcs is the sum of those two arcs. So if I want to say the measure of arc ABC, it is the measure of arc AB plus arc BC. Okay, so I can say the measure of angle of arc ABC is arc AB to arc BC. Okay, so let's do this using some numbers. Let's find the measure of arc GE. So when I'm going from G to E, I can go the short way or the long way. So the long way is more than 180 degrees, which that's a major arc, and I need 3 letters, so I know I'm going the short way. So this is going to be 40 plus 80. 40 degrees plus 80 degrees, which is 120 degrees. So arcs are measured in the units of degrees, just like angles. Okay, so arc GEF. So GEF, so I'm going in this order. So I want to go in this order, so I'm going to add 40 plus 80 plus 110. 40, 80, and 110 is 230 degrees. Okay. What about a measure of arc G2F? G2F. So I know going all the way around is 360 degrees. So I can start with the total and subtract out all the parts. So minus 40 degrees, minus 80 degrees, minus 110 degrees, which is 130 degrees. Okay, so let's classify some arcs here. Find the measure of each arc of circle P, where segment RT is a diameter, and classify each as minor, major, or semicircle. Okay, so let's start out with the first one, R to S. So from R to S, I'm only using 2 letters, so I know I have to be a minor arc. I also know it's 110 degrees, which is less than 180, so I know it's a minor arc. All right, let's try RTS. So RTS, I have to go in the order of the letters, so I'm going this way. So I know this is a major arc. Part of it I knew I was, it said find the arc and classify it. So this we said is 110 degrees. So this is going to be, I know the whole thing is 360 degrees minus the 110 that does not include it is 250 degrees. 250 degrees. I could also say this is 180, and I know this is 70 because when I add 110 and 70, it's 180. So an alternate way I could say 180 plus 70 is 250. Okay. And let's find the measure of RST. So RST, that is a semicircle. Okay. So it is a major arc, but the most correct answer is semicircle. So this is a special case. Okay. All right, let's solve some problems. Okay, a recent survey asked teenagers whether they would rather meet a famous musician athlete, actor, inventor, or other person. The circle graph shows the results. Find the indicated arc measures. Whom would you rather meet? So the measure of arc AC, so AC is from here to here. So this is going to be 29 degrees plus 108, which is 137 degrees. Okay. What about the measure of arc ACD? So ACD. So I'm going to add all these up. So 29 degrees plus 108 plus 83 degrees. So this turns out to be 220 degrees. The measure of arc ADC. So ADC, since I'm going this direction, so this is going to be 79 plus 61 plus 83 degrees, which is 223 degrees. The measure of EBD. So E, then I'm going to B, and all the way around to D. So I can either add up all the arcs and say 79 plus 29 plus 108 plus 83 and get 299 degrees. Or I could have just started out with the whole thing, which is 360, and subtract out the one I don't have, which is 61, and also get 299 degrees. Either way, I'm going to get the same thing. Okay, congruent circles and congruent arcs. So two circles are congruent if and only if they have the same radius. Congruent arcs are congruent if and only if they have the same measure, and they are the same circle or congruent circles. So they have to have the same measure and be congruent circles, which means they have the same radius or be the same circle. Okay, so let's check. Okay, arc CD, I'm asking about CD and EF. So do they have the same measures? So the arcs are equal to the central angles. So yes, they have the same measures, which are 80 degrees. Are they the same circle or are they congruent circles? So these are the same circle. So yes, this is true. So are my arcs congruent? Yes, they're congruent because they meet both criteria. Okay, let's check. Arc RS and arc, the measure of arc TU. These are the two I'm comparing. Are they the same measures? So these are both 90 degrees. And I know that because we're equal to the central angle, so they're same measures. Are the same circle? No. Are they congruent as the radii equal? So this is a radii of this length and this is a radii of this length. So no. So the answer is no. I do not meet both criteria. Okay, let's try number 6. All right, let's check arc UV. This is 95 degrees, and arc YZ, this is 95 degrees. So do I have the same measures? Yes, they're both 95 degrees. Are they the same circles? No. But are they congruent circles? And I have the same radius. So yes, this is true. The radii are equal, so yes. Both criteria are met. So yes, my arcs are congruent. That's it.